Hello guys, welcome to Self-Help Maths Academy. So today we're going to discuss about the important concept that is limits which are involving infinity. So limits involving infinity. Okay, so let's see. Uh, First, let's see what are the in general rules we have with respect to the limits. So if we have limit, say 1 over xn as x is tending to plus or minus infinity, this will be equal to 0 if your n is strictly positive. This is the first one. The second one says this is important whenever you have any of the form like 1 divided by x to the power n form, and where n is positive, then the value of the limit will be 0 as x is tending to positive or negative infinity. And then we have limit x to the power n as x is tending to infinity is equal to infinity. This is if n is greater than 0. If n is greater than 0, then x to the power n as x tends to infinity will be infinity. Then similarly, we have say limit as x tends to infinity, x is tending to negative infinity. This value is positive infinity if n is even, and it is negative infinity if n is odd. So if depending on the end value, whether it is odd or even, we have positive and negative infinity. And if, for example, we have got the function of, or like the rational function form, f of x divided by g of x, say limit as x is tending to plus or minus infinity. If this form of examples we have, then where f of x and g of x both are polynomials, then we first divide all terms by the highest power, by the highest power of x that appears in the denominator. Okay, in the denominator. So what we do is, whenever it's a rational function, so we will just see what is the highest power in the denominator, and then we will divide all the terms by the highest power of the denominator. Let's see. Now we're going to have these three rules, and let's see the examples one by one. How do we approach to the example? So the first example here goes like this. Say limit of 4 as x is tending to infinity. If you see this particular example, where this is the number which is free from x, so there is no problem whenever you have a constant function where you're having a limit as x tending to infinity, it will be just the constant itself. And then let's see another example. You have limit 3 minus 2x as x is tending to infinity. So here you can see by the limit rule, if you are approaching, so this is like two functions, addition and subtraction f minus g. You can just separate the limit. You can write it as limit 3 as x is tending to infinity minus limit 2x as x is tending to infinity. And here you can see this is a constant function, so there will be no change. You can write it as it is. So here you can see this is the limit as x is tending to infinity, where here n, this is 1, which is greater than 0. So hence this limit will be infinity. Okay, as per the second rule. So anything minus infinity will be again infinity. So this is the answer. Let's see the third example. We have limit, then 2 minus 3x divided by 2x plus 5. Then as x is tending to infinity. Now we can observe this function is like f of x divided by g of x. And we have discussed that whenever it is of this form, then we need to find out the highest power of x in the denominator. So in this case, you can see the highest power of x is 1. So we can just take it out. This is equal to limit as x is tending to infinity. So here we can take this x out, the denominator. So this will be 2 plus 5 divided by x. And here also you have to take x, because whatever we are taking in the denominator, we need to take it up. This is also x. If I take, this will be 2 over x minus 3. Now this is your function. Okay, so I can cancel here this x which you're saying on both numerator as well as denominator. Now this will be equal to, okay, this will be equal to now limit as x is tending to infinity 2 over x minus 3 divided by 2 plus 5 over x. So now simply wherever x is, the substitute the value. So this will be 2 over infinity will be 0 minus 3 divided by 2 plus 5 over infinity will be again 0. Answer is minus 3 over 2. This is the limit of this particular function. Let's see another example. Okay. So in another, this example, we have got, say, limit as x is tending to infinity. So we have got negative infinity here. So this is 1 plus 2x minus x square divided by 2x square plus 3x minus 4. This is equal to. Now you can see x square is the highest term in the denominator. You can just take out that, right? Limit as x is tending to negative infinity. So in the denominator, we can take x square out. Here we're left with 2 plus 1x will cancel. So 3 over x minus 4 over x square. Similarly, here also you take x square out. This is 1 over x square plus 2 over x minus 1. So this is the function. And here you can see, we can cancel this x square and x square. So we are left here with, and also you can see, you can apply the limit as x is tending to negative infinity. So this value will be equal to, this is equal to 1 over infinity. This is 0 again. This is also 2 over infinity is again 0. So this is negative 1 divided by 2 plus 0 minus 0. So the answer is minus 1 over 2. Okay, so this is how we are solving the examples with respect to the limits. Let's see another example. We have got, let's see, limit as x is tending to negative infinity. We have got 1 minus 2x square upon 3x plus 5. So again, in the denominator, the highest power is x. So x is tending to negative infinity. So we can take x out. This is 3 plus 5 over x. And here it is, if you take x, it is, because you can take x here, 1 over x minus 2x. If I take x out. Okay. So this is now, as we have this x and x, we can cancel. So simply we can simplify this is equal to limit as x is tending to negative infinity. Here we're left with 1 by x, and here it is minus 2x divided by 3 plus 5 over x. So as we substitute the value of x, this will be, you can see, infinity over this value will be some number. Okay, so we know infinity divided by 0 will be infinity. Actually, you get here, this is infinity. Sorry, 1 divided by 0, this will be 0 here, minus this will be infinity, and infinity, and this negative sign is infinity divided by 3 plus 0. So therefore infinity divided by the number, again this is infinity. So the value of this particular limit will be infinity. Okay, so this is how we are going to solve the examples which are related to infinity. Okay, so basically we have to remember these three rules when you're solving the problems related to infinity. Okay, so I think with this another last example I'll be taking it here. Let's see another example which involves x divided by square root of 4x square plus 1, limit as x is tending to negative infinity. Okay, so this is equal to, you can see in the denominator you have x square. So let me take this limit as x is tending to negative infinity, x divided by, in the square root if I take x square out, so this will be 4 plus 1 divided by x square. So this is the square root, and in the square root, so it will be, when I take it back, it will be x. This is equal to limit x divided by x into square root of 4 plus 1 over x square as x is tending to negative infinity. And clearly we can just cancel it, this x and this x. So therefore we are now good to go with substituting the value of x as infinity. This is equal to 1 divided by square root of 4 plus, if I substitute infinity, this value will be 0. So hence 1 divided by square root of 4 is simply 1 over 2. This is the value. Okay, so like this we can solve the examples which are related to the involved infinity in the given example. Okay, so I think this is all in this video. In the next video we'll come up with the next topic and next concept. So till then, take care guys, see you on the next video. Bye.